Hello, I'm going to talk about our project for a little bit. We had a group project consisting of 3 people, Sam Peterson, Nathan Hawes, and Nick Elmer, and together we created a motion-controlled RC car. So we took a gyroscope that was an external device on our microcontroller's board. We took readings from it in order to read motion controls, which we used to send signals to the remote of the RC car, which would then tell the RC car where to go and what to do. Between the microcontroller and the gyroscope, we used SPI communication to serial peripheral interface. We configured the microcontroller to be the master, while the external gyroscope was a slave. The microcontroller provided an 80 megahertz clock signal to drive the gyroscope's clock. We also had 3 other lines connecting the 2 devices: a master in, slave out, a master out, slave in, and a chip select line. The chip select line was an active low, so whenever we drew that line to low, that enabled the gyroscope for SPI communications. The gyroscope took readings from 3 axes: the x-axis, the y-axis, and the z-axis. We only needed to use the readings from 2 of these axes, the x-axis and the y-axis, in order to control forwards and backwards motion and left and right motion. The gyroscope provides angular velocity signals, so we configured the controller to activate to send a direction whenever we reached over 200 degrees per second along either of these axes. We configured the SPI to use one-line, bidirectional, and full duplex. Because of the way SPI information protocol is set up, we need to send information every time we receive information. Because we only care about our readings from the gyroscope, we ended up sending a dummy byte to the gyroscope every time we wanted to receive information. So we would send the letter F to the gyroscope, and we would receive the relevant gyroscope readings back from it.
For the physical setup of this project, we took a pre-existing RC car and the controller, which is inside this housing. And we noticed when we were looking at the board, that is the remote control, that for controls that there were 4 buttons, each of which connected from the controller to ground when they were pushed. So what we needed to do is, from our microcontroller, set 4 pins that would drive to ground when we wanted them to, in order to control the forward, back, and then the turning. In order to do this, we set each pin to be output, open drain, and pull up. Now, at first we tried doing pull up, pull down instead of open drain, but this, on the remote control board, it interpreted both the high and the low as low, which caused it to cause the signal to be sent both when we wanted it to be sent and not, so continuously high as an output. So by setting this to open drain, it would sync to ground when we set the pins low. We also realized that we needed resistors in there because our board can only sync so much current per pin. So we put 1000 ohm resistors in between the pins and the board that goes with the remote control. We knew that the gyroscope returned in degrees per second instead of just the position that our hand would be in. So instead of implementing a position-based system, it's a velocity-based system. So as you'll see later in the video, it is a flick motion to control the car. And within our code, we compare the output of the gyroscope, and if it reaches 200 in either direction, positive or negative, in the X direction, which is what we use for acceleration forward and backward, and Y direction, which is right and left, we then change state to control the car appropriately. After each one of those signals is received, there's a delay of 200 microseconds in our code that keeps the code from receiving too many signals from the same motion. Because if that delay was not there, it could interpret one flick as multiple inputs, thus changing the state more quickly than we'd like. After it goes through that delay, it then changes the pins to drive the board, which will then send the signal to the car and have it go. Forward. You have forward motion with the wheel, backward, to the right, and to the left.